The next presentation about OPC Foundation standpoint for the OPC UA technology, which we already heard from Martin Hankel. It's really enabling smart manufacturing through the standardized communication technology, and I will tell you more about those details behind that. The OPC Foundation is an international organization which has different kind of branches all over the world, and we see that most of the members are from Europe. There's 50% of the membership in general coming from Europe, but it's a very international organization. We have more than 500 companies as members of the foundation. And the board is also very international. We have members in different countries from different players, key players like Microsoft, Honeywell, SAP, Beckhoff, Siemens, Yokogawa from Japan as well. So it has a very good basis for international collaboration as well. And the key persons in OPC Foundation are two very active persons, Tom Burke, the president, who's been running the OPC Foundation for 20 years or more, and Stefan Hoppe, who has been also very active for the last 10 years, arranging first the OPC Day Europe events, and nowadays Stefan is just flying all around the world every week, almost in different part of the world, doing the promotion of OPC technology. And they are really important guys, and as I mentioned, they are at the moment in the North American seminar tour, where they are hosting this year altogether 11 events in different cities in US. US is a big continent, so we need a lot of different events like this to catch a big number of people and bring the technology into US as well, and Canada, of course. OPC Foundation has different membership layers. The class A is for the biggest companies, and this shows you the main players that are taking part in the foundation work. So you see in practice all the main automation vendors as taking part in the OPC Foundation. And most of the OPC Foundation work is accomplished by volunteers in these companies doing all the specifications as joint work. So it's not driven by the foundation itself, it's mainly driven by these companies that are doing the job. At the moment, there's an analysis that there are already 35,000 OPC products in the market, and over almost 50 million OPC installations. This is projected to almost double, especially the installations over double for next year. So we are really seeing OPC UA catching fire. Of course, this probably mentions also the classic OPC products, which are laying the background for the technology, but today I would see that it's mostly OPC UA technology that is going forward. So what is OPC? Actually, how many of you is not familiar with OPC UA before today? Okay, good. A short background. Of course, we started with the classic OPC. We're still talking about that, and that was the Microsoft DCOM-based technology. And the main part was that we had 3 separate protocols, or actually a couple of more coming, but these 3 were the ones that were accomplished in practice: data access, alarms and events, historical data access. But they were providing a lot of practical problems, so OPC Foundation started the rework of a new protocol that was established already 2009, the first release of OPC UA, the Unified Architecture technology, which combines the old separate protocols into a unified architecture. And the main advantages that we get now is the platform independence, built-in security, and what I like to say is the most important in future especially is the information modeling that OPC UA brings to the table. And the specification is defining this kind of layered architecture. We have abstract models for the communication part, for the transport, data modeling rules, and common base services. And on top of that, we can build different information models. For example, bring the old models on thin layers on top of this, and then there's a chance for bringing all different standard models on top of these, and then vendor-specific extensions on top of the other models. And it was standardized as IEC standard already over 5 years ago as well. In general, OPC UA enables secure industrial internet, which means smart manufacturing, smart cities, and smart anything. In the world, we have these initiatives that are taking place that Martin already introduced a little bit. In America, we have the IIC, in Germany, Industry 4.0. In Korea, they have another manufacturing initiative, and it's the Manufacturing Industry Innovation 3.0. And in China, there's a program called Made in China 2025. And all of these organizations are looking at OPC UA at the moment. In America, there's the reference architecture model called Industrial Internet Reference Architecture, and they have a connectivity framework where OPC UA is defined now as an alternative. And there are 3 test beds with integrated OPC UA happening there. I think most of these also started with German initiatives in Industry 4.0. So already in 2015, there was a recommendation that OPC UA is the communication technology to use. And now, this year, the requirements came to the table that OPC UA is now a mandatory requirement for the communication part, as Martin already showed as well. And it's also mentioned here as the information technology. I will see that this will probably get more attention later on, this information modeling, because I don't think there are as good alternatives for modeling information in general. OPC UA is kind of standardizing that as well. In Industry 4.0, they're defining different criteria. So the basic criteria is what products are expected to contain today. In future, there are more full-fledged criteria set for the components. This is still valid, I think. Yeah. In Germany, there's another organization, the VDMA, which is kind of looking at different industries, different markets, and they are representing mostly medium-sized companies, and they already also laid out a guideline about the Industry 4.0 communication with OPC UA. This is still in German only, but the English translation is to come. And VDMA is now taking a bigger role as well in this, especially on this modeling part. And they also lay out the importance of OPC UA, how it fits in these communication and information layers in the reference architecture model, and enable the implementation of the administration shell that was presented to us in the previous presentation. In Korea, they have the Manufacturing Industry Innovation 3.0 in response to the paradigm shift of the 4th industrial revolution. That's where the 4.0 comes to Industry 4.0. I don't know why they picked 3.0 in Korea, but they are aiming for 3 achievements for high productivity, flexibility, and resource awareness, and through 3 technologies: the automation, production, and ICT, with a combination of these. And I would say that nowadays we are talking a lot of combination of the operations technology and information technology, the OT and the IT side that used to be more separate from each other, but we are seeing more and more mixing up of these, and there we need more and more advanced technologies, especially the security will be playing a key role, but also these communication standards and the information modeling. And that's why I think we are seeing a lot of these type of initiatives taking place at the moment. By 2020, they are expecting this to spread to smart factory technology to over 10,000 enterprises in Korea, but also internationally. And especially OPC UA will be used as an industrial standard for the connection between the OT and IT. And there was a ceremony of Tom Berg and Stefan Hoppe attending this in Seoul this year, where this was established. Finally, in China, there's a national standard that they are making up for the Made in China 2025 initiative. The Chinese really want to be the most advanced smart manufacturing country in the world by 2025. That's their main target, and I don't have any doubts that they will actually be that. We have maybe the vision that Chinese production is very old-fashioned, but they have very big initiatives going there, and they are very efficient in changing their technology to greener and more efficient ways. And they are taking the OPC UA specifications, which is in several parts. Already parts 1 to 8 have been completed. They've taken them to Chinese versions, Chinese standards through this technical committee 1 to 4, and the rest will be completed still later this year. There's a couple of statements from key players from China. You probably can't see it there, but you will get the material later on where you can read these statements. This from Instrumentation Technology and Economy Institute, where they say that this standard will promote that the device manufacturers should provide OPC UA servers for their produced devices directly, and the software vendors should better to embed OPC UA clients. And from Huawei, we get a statement that OPC Foundation is an essential part of that emerging ecosystem. It defines OPC UA, a standard that is fundamental to linking the ICT and OT environments in a way that is both secure and forward-looking. So these are the kind of statements that we see from key players in China, and I think the same aspects are very much true in all over the world at the moment. So a bit more about the technology behind OPC UA. We have the key benefits that we have now with this layered technology, and in general it's providing a really good collaboration platform. And if we look at the communication protocols that we had the question as well, OPC UA is at the moment based on TCP/IP session-based client-server protocol. We have alternative communication transports, and we have full security. So whichever transport alternative you select, you have the same level of security. That's the main idea. But although development started with the SOAP and web service-based technologies. That was actually deprecated from the latest version of the specification because that was too .NET specific implementation that was defined. And in practice, we see all products supporting the OPC UA binary communication protocol. We introduced an alternative to use HTTPS, where we're taking this same binary protocol in general through, but the main use case would be to get through some firewalls that are detecting the traffic easier than with the binary protocol. But the binary protocol is in general the most efficient version. It's very optimized and it has the same level of security anyways. Actually, we have more control on the security protocols that we want to support here and more flexibility on that. But the main idea is that we have flexibility here, and actually for the next version 104, which is still due to end of this year, but I rather promise it for the next year, we will also get the WebSocket alternative communication protocol based on JSON messages and that. That will help building JavaScript web clients, for example, which has been quite difficult so far. So we've needed gateway products like what was mentioned here, like converting OPC UA to REST protocols, for example, which is still a viable solution. But if we want to go OPC UA direct from the browser to the servers, then we need WebSocket communication there. Okay, but the main thing here is that we have a flexible definition. Nothing is written in stone. Everything can change. We can deprecate all protocols. We can introduce new protocols as necessary. And security is playing a key role here. If you wonder about these port numbers, they are just examples. In general, all applications can define the TCP port numbers. 4840 is the standard OPC UA port number that is mostly used by especially PLC devices. But if you have several servers running in the same computer, you can have different port numbers, and then there's probably a discovery server running is port 4840. Okay, I just mentioned that OPC UA is client-server based, but there's actually also going to be a new extension to this in the next release for the publisher-subscriber version of OPC UA, and there will actually be two alternatives for this. The first one is a UDP-based secure multicast, where we are approaching even real-time communication, so we get as fast communication as possible through UDP broadcasts. And we will hear more about this in the later presentations, especially about the TSN. And another alternative, which is quite different, is targeting the cloud-based communication, but the same principle is here, that we have publishers that are just publishing measurement data, and then we have a number of subscribers that can subscribe to the selected part of the data. This is, will be based on the AMQP message queue protocol at first, but MQTT, XMPP are also being introduced in future as possible. I've understood that AMQP is the easiest one of these to really take advantage of. AMQP comes from Advanced Message Queue Protocol, so it has functionalities and features that the simpler ones like MQTT are missing. And there are people who really don't like MQTT in practice because of its limitations, but probably you all know that it seems to be the most popular message queue technology that's being used for cloud-based architectures at the moment, so we really need to look at that as well. So two different publisher-subscriber protocols. I'm afraid this will confuse people in future, but they both share the same principle, that we have publishers that are publishing a fixed set of data, and then we have subscribers that can select which ones they want to monitor. In the traditional client-server model, we have more flexibility in deciding, for each client can decide which data they want to monitor and how fast and so on. But in general, OPC was never meant to be real time. Now it seems that it might be possible after all. The security model in OPC UA is layered. We have an option to sign and encrypt all messages on the transport layer. We can authenticate all applications with application instance certificates. We can authenticate users on top of this. And then we can authorize on the application level or let the applications authorize operations, reading, writing, changing the state of the machines, depending on which applications are connected, which users are connected. In Germany, BSI, the Federal Office for Information Security, made a security analysis of OPC UA, both for the specification part and for reference implementation. And these results are now available also in English. You can go to the OPC Foundation website where you find the commented version, or you can go to the BSI website where you find this analysis. And as a generic overview of this analysis was that OPC UA is defining these different security modes that the configurator of the network or the communications can choose from. Whenever you're making connections, you can decide which level of security you want to use. And the recommendation from BSI was that you shouldn't go without security if you want security. But if you go with the secure versions, especially with the sign and encryption, you get really good protection from almost all security threats that exist in general. Of course, there are things like denial of service, server profiling, which are very difficult to protect from, and that's what I like to say, that if you want to take OPC UA services to public internet, you better know what you're doing. But it's also good to know that there are other technologies that can help you with protecting the services, and we will have something regarding this coming up with the Process OPC presentation later on in the afternoon as well. But there are products that help protecting with these threats as well. In general, OPC UA is not used in public internet. You use it inside your factory and try to protect from kind of external attacks coming into the OT side of the factory in general, or to the communication side. And of course, what level of security you need depends on your use case. But OPC UA is providing the means to secure the communications. Information modeling is the more interesting part, and OPC UA is defining a basic concept for defining the modeling rules for different models, and this can be used to take in standard information models, make them OPC UA way, or you can define your own models. And the key thing here is that OPC Foundation is doing a lot of international collaboration with different organizations that already have defined different information models. So the idea of OPC Foundation is not to reinvent anything, not to create new models, but rather to convert them to a standard language. And the network here is extending all the time. We are signing more and more agreements with different organizations, and we are getting more and more work related to this happening at the moment, and I see an increasing speed here. We have already collaboration with organizations and existing models in different fields. automation measurement field in different verticals. On the enterprise level, we have ISO 95 model, for example, already. And on the engineering, we have PLC Open Automation ML model and DXP model coming up, which we have another presentation in the afternoon. And the VDMA that I already mentioned is looking at different fields of industry. And at the moment, they are concentrating on several models already. For example, there's a robotics working group defining a common model for robots. And there's an injection molding model for Euromap 77 and things like that that are active at the moment. But they will be really kind of taking more initiative in this collaboration as well. News from OPC Foundation. The foundation opened 2 new certification labs this year. First in Germany, beginning of the year, and now already also in China. These are to help with certifying OPC UA products. This is important for the users and users that you get certified products, that they really implement the functionality of the protocol as it should be. And there's also new openings for non-member companies to be able to certify products without the membership fees that used to be the pre-requirement for getting to the certification lab. There's still work to be done on that, but it's opening up. And actually, another thing is that the company specifications, the information models, will be coming to the certification in future as well. So we have a kind of flexible model. OPC UA is containing a lot of different functionalities, features, and all of these features don't need to be implemented with all the products. So we have ways to define which functionalities are implemented with different products, and the end users can then see that which models, for example, the products are supporting. But this will be more for future. At the moment, we don't see any testing happening for the information models, for example. But regarding to this, there's also a new membership category, UA logo membership. Till now, the logo was only available for corporate members in general, but now the idea is that also non-members who are just using, for example, toolkits to bring OPC UA functionality into their products can apply for OPC UA membership, but just for the purpose of getting the logo, rights for using the logo with the product, and also for the certification purposes. We are seeing different trends happening with the OPC UA. There's service-oriented architecture is moving from this kind of layered design. We're seeing the manufacturing different services that are coming up in different parts of the manufacturing, and communication between services is getting more and more important, and that's where OPC UA is playing a key role. Another thing is cloud services are getting more and more attention. There are big vendors like Microsoft, Oracle, Amazon that are providing more and more cloud services, and people are really embracing these at the moment. Microsoft has been very active. They've been implementing OPC UA in Azure IoT Hub. And Microsoft has actually been very active with the OPC specification work and also implementation of reference stack layers in the recent years. Last year we had a Microsoft presentation at the OPC Day Finland. This year Eric Barnstedt, who's the main architect behind this, is also traveling with the OPC Foundation seminar tour in North America. But we also visited Microsoft headquarters in Seattle a couple of weeks ago, where Matt Vasey, who is the board member of OPC Foundation, was hosting an event as well. So Microsoft is really active with OPC UA at the moment, and they really want to embrace that. And one key aspect is the Azure cloud. I'm not going to the details of the diagram, but they have different components where you can take Azure to kind of manufacturing use. Another trend is that OPC UA is moving to lower-end devices. There are already chip-level implementations in the market where you can just buy this from Hillshare. For example, you can just buy small chips. I think this is already magnified picture of that small chip that contains full OPC UA implementation inside. They have a chip that's implementing different industrial protocols inside, and OPC UA is one alternative over there. They also have gateways, and there are a lot of companies now providing these gateways that can convert between different protocols. IO Link is something that's catching a lot of attention at the moment as well, for providing a standard for IO definitions, and there's OPC UA activities happening with that too. Okay, we don't have chance to go to the technical details today or deeper in these things, but OPC Foundation has created a lot of different video broadcasts also for the companion models. There's an extensive set of these available from YouTube. You can go to the Foundation channel or look at these links mentioned here. So that was the short introduction to the technology from my point. Any questions at the moment?
Okay, so my name is Mahabub, and I came from Marimetic. So we are using OPC UA, but I am just curious to know what are the alternatives we have in the market, like a competitor product in market that, for example, if I don't like to use OPC UA, what option I have? What are the competitor products?
You mean if you want to get products that implement OPC UA?
Yeah, just like work as OPC UA.
Yeah, I didn't have a chance to bring here the number of products that are available, but we are seeing the key vendors like Siemens, Beckhoff, Bosch Rexroth. We are getting the introduction of those products in the afternoon. Siemens not today, but we hosted an event 2 years ago. Siemens is supporting OPC UA at least in 11 products at the moment, and they are bringing it to more and more products in the market. The Americans have also brought products like Emerson, Rockwell, and brought products finally this year. We've been waiting for that quite a while. But we've seen a lot of products supporting OPC UA, especially the German PLC manufacturers and automation system vendors. But what we see ourselves as provider of OPC UA toolkits is that OPC UA is used in a wide scope to create kind of interconnection between different traffic monitoring systems, or in the fields where traditional automation industry was not that big. And we have the install base of old OPC classic products, which is still dominating in the manufacturing industry, and those are changing to OPC UA gradually. And I think most vendors, I mentioned Honeywell, didn't mention yet, and all these, they have the alternatives. If not yet, they are building them already. But I've seen it mostly happening first from the small manufacturers, but the big players are bringing those to the market as well.
I raised this question because we have a customer in Korea, and they don't want to use OPC UA. So we have to find alternative because they want to somehow stuck with BACnet, for example, and that is built on top of MQTT. So it's basically pub-sub mechanism they are using in BACnet. So is it so that in USA they use BACnet as an alternative to OPC UA?
Yeah, it's true. There are these existing communication models, MQTT, BACnet, and all these. And what we are doing with the OPC Foundation is we are embracing those technologies and bringing them through OPC UA as an alternative communication protocol, but information protocol as well. So OPC UA is rather embracing those and bringing a standardized layer on top of these different communication technologies. But it is true that people still prefer to use the MQTT, for example, as it is. But they will, at some point, they will head into the problems when they notice that when they're mixing different systems together, that it doesn't provide all the functions and features that OPC UA is providing. So they are, you could say that they are competing technologies, but with OPC UA, we try to bring more things available out of the box than the other protocols are providing. And that's the key challenge, how to educate people that OPC UA is more than a protocol, that it's kind of raising the level of integration from the plain transport layer to the higher layers. But it is much more complicated to get the complete picture of it because it contains so much different things. And in practice, we are kind of in that situation that many people don't see the benefits of OPC UA because they see it as a competing technology, whereas we would like to see it as an advancing technology and not a competing technology.
Thank you.
Any more questions? Okay, so the next question is how long do we have time to enjoy the coffee?